Hello students, today we are going to do one experiment. The aim of the experiment is to determine resistivity of a wire by plotting a graph for potential difference versus current. Means in this experiment basically we are going to do two things. First is we will once verify Ohm's law, we will cross check Ohm's law, and through this verification we will find out the resistivity of the material of a given wire. This is our aim. Next I am telling you that what is the working principle behind it. As I have already mentioned that it is based on Ohm's law. So according to Ohm's law, you know that if we state Ohm's law, that temperature, pressure and other physical quantities remaining the same, the current flowing through a conductor is directly proportional to the potential difference applied across the ends of the conductor. So accordingly we can write that here in this particular circuit, as you can see, there are several circuit elements. So in this circuit we will control the current, and that current will pass through this resistance, and the potential drop across this resistance will be measured. So this experiment is basically the measurement of current and potential difference. So from Ohm's law we get V is proportional to I, or V equals to I into some constant R, which is actually the resistance, and we have to take care that other physical conditions, temperature, pressure should remain constant. Okay. So R equals to V by I. Now further I can say like the resistivity of the material of the wire, rho is given as RA by L. Some experimental wire will be given over here, and that wire is having some area of cross section A, length of the wire will be L, and R is the resistance which is to be found out from the experiment, and finally we can find out the resistivity of the material of the unknown wire. So rho is finally coming pi r d square by 4L. Here we have replaced A as pi d square by 4, which is the area of cross section of the material of the wire. Now let us come to the circuit. Now before explaining about the circuit elements one by one, first is the battery. This is actually called the DC power supply or the battery eliminator, right? And here you can see there is a potentiometer connected over here. So we can scale up or scale down the voltage from there, and there are two terminals, one is positive terminal, another one is negative terminal. Okay. So this is the power supply, and there is a on off switch connected over here, which is already given in this particular circuit that you can see. Just after the battery in series a switch is connected. So in this particular device also that switch is this one. So this is all about the power supply. Okay. Next is, after that comes the rheostat. Rheostat is basically a variable resistor. This is basically a variable resistor. Here you can see there are three terminals in the rheostat, and this is a slider. So we can vary the resistance in the circuit with the help of this rheostat. Okay. So out of these two terminals, one is connected and this one is connected because it acts as a potential divider circuit. So in that case one terminal will go here, another will be going towards the slider. Okay. So how much length is covered, that much resistance will be effective in the circuit, rest of the wire will not come, and rest of the resistance will not be counted in the circuit. Okay. So this one terminal is this one suppose, and another will be this one, then the resistance will be counted from this end. So this acts as a potential divider circuit, which is known as rheostat. So just by varying the resistance in the circuit we can control the current. Basically we can control the current. This is about rheostat. Next we can see some unknown resistance whose resistance needs to be found out, and finally the resistivity of the material will find out. So that unknown resistance I am showing, this one is actually a kind of unknown resistance that you can see here. A piece of resistance wire, it may be of constantan, okay, or manganese, any resistance wire can be wrapped around this wooden frame. So this is the unknown resistance. The length of the wire here we are taking for this purpose as 30 centimeter, and area of cross section can be found out by finding its diameter using a screw gauge. Okay. So this is the required wire of having unknown resistance. Next is, as we can see, a voltmeter is connected across an unknown resistance. If you see the circuit, a voltmeter is connected in parallel with the unknown resistance. So what is that voltmeter we are using? So our next circuit element is here a millivolt meter. Now this is written MV. Now why we are using this instrument? Because here the potential drop across the unknown resistance will be in the order of millivolt. Hence we are using this millivolt meter. Now before using this instrument we need to know three important parameters related to this instrument. First one is the range of this particular circuit element. What is the range? Now if you see, if you notice here, the readings are ranging from 0 millivolt to 250 millivolt. It is ranging from 0 to 250, okay, 0 to 250 millivolt. Now if you see any division, if you see, suppose I am telling 100 to 150 millivolt. So within this interval of 50 millivolt, there are 10 small divisions. So each division corresponds to 5 millivolt. So this is called the least count. So the range of this particular millivolt meter is 0 to 250 millivolt, and the least count is 5 millivolt. Third one is the zero error. What is this zero error? Any instrument can have some error, some instrumental error can be there. So we have to check this before using it. So what is this error? Before connecting this instrument to the circuit, we have to see whether the pointer is reading towards 0 mark or not. If it is not in the 0 mark, then it must have some zero error, and we have to take that in account, and that zero error can be adjusted also. So as we can see, in this particular instrument there is no zero error, and whatever instrument we will use in the circuit, that will also not have any zero error. So we can easily mention that the zero error or the instrumental error is nil here. So whatever will be the observed value, that will be the corrected value in our experiment. Okay. Next we can see another circuit element. Here also we are using milliamp meter. Here also the range of current that will be flowing through the circuit is in the order of milliampere. So we are using here a meter. Here the range of the milliammeter is 0 to 250 milliampere. 0 to 250 milliampere. If you see the scale, if you notice the scale properly, it will be 0 to 250 milliampere, that is shown. Similarly here also, like from any division, if I count, suppose 100 to 150, if I count 100 to 150 milliampere, there are 10 divisions. So here also in the same manner, each division corresponds to 5 milliampere. That means the least count here is also 5 milliampere. And here also there is no zero error, because when it is not connected to the circuit, the pointer is actually pointing towards the 0 mark. So this instrument is also errorless. So this is about milliamp meter. So these are the required circuit elements which are used in the circuit. Now let me show you the circuit connection. Here if we start from the positive terminal of the cell, then it is connected to the positive terminal of the milliamp meter, as you can see in the circuit. Then with the negative terminal, we connect the one end of the unknown resistance, and then another end of the unknown resistance will go directly towards one terminal of the rheostat, then rheostat to the key, and then key to the cell negative. Now a voltmeter is connected in parallel with the unknown resistance, just to measure the potential drop across this particular resistance. This is our experimental data. So we will get all the readings from the voltmeter, or if it is a millivolt meter, then you have to write here MV, millivolt meter, and this is the milliamp meter. So these are the two circuit elements from where we will get our data and we will write it in the experimental table. Now let us see the actual circuit physically here. So according to the circuit drawn on the board, we have made this circuit. So from cell to the milliamp meter, from milliamp meter to the unknown resistance, this one is the unknown resistance, from unknown resistance to one end of the rheostat, and another end we are connected to the negative terminal of the cell, and the voltmeter is connected in parallel with the particular unknown resistance. This is a very simple circuit given over here. Now I will explain you how to take the readings first. So let us see once more the circuit element. In this particular circuit, you can see that this unknown resistance R is in series combination with the resistance as given in the rheostat. Okay. So if we vary the slider in the rheostat, then the effective resistance of the circuit is going to vary, which will finally vary the current flowing in the circuit, the total current, and that current will flow through this particular unknown resistance R, and accordingly the potential drop will be there across R, and which will be shown by this particular voltmeter or millivolt meter. It is according to your requirement in the experiment, it will be shown by this. So what is our job here? We will take 4 to 5 observations. In each observation, we will vary the rheostat over here just to vary the resistance of the circuit and hence to vary the total current. So that current reading, the variation of current can be shown from this particular milliammeter. We will note down that value, and this much current, since it is flowing through this particular resistance, so automatically the potential drop also will vary, which will be shown by this millivolt meter. So we will just vary the rheostat, take the readings from the milliammeter and the millivolt meter, and in the table we will write all the data. So this is the procedure in the experiment. Now let us move on to the observation table part on this side. See, so this is the observation table to determine the resistivity of the material of a given wire. Okay. Now the first column is, we have kept here current as the first column, because here current is the independent variable. We are changing the current as per our choice by changing the slider in the rheostat. If we vary the resistance in the circuit, then automatically the current will vary, and accordingly the potential drop will be observed across the resistance, unknown resistance R. So current is the independent variable, and so we have kept it in the first column of the observation table. So this is the first column. Second one is the potential difference in millivolt, as we are using a millivolt meter over here. So potential difference in millivolt. Then using Ohm's law, we will find out the resistance as R equals to V by I. You know, R equals to V by I. So for each observation, we will have different values of different sets of I and V, and corresponding values of R we will get from here. After that, using using this particular formula for finding resistivity, rho equals to RA by L, or you can see rho equals to pi R d square by 4L. Using that value of R from the observation table, we can put the values, and different values of rho we can find out. Now let me tell you one thing from here. For finding the value of rho, these are the parameters required. Now pi is a mathematical constant, R is the resistance which can be found out from the particular experiment from the observation table, and capital D is the diameter of the particular wire, that experimental wire whose resistance we are finding out. Now with the help of the screw gauge, we can find out the diameter, and the diameter of the wire is found to be 33 millimeter. This we have calculated, we have seen, and you have also used in class 11 that how to use a screw gauge and how to find out the diameter of a very thin wire. So using the same method, we have found out it is found to be 33 millimeter. So D is 33 millimeter, and already I have told the supplied wire is having a length of 30 centimeter. We can repeat the same experiment with another wire of different length, okay, just to see that whether Ohm's law is verified or not. Okay. So this way the rho can be calculated, and we can in that particular observation table, if you just see this, that rho can be calculated for different values of rho we will have, and in the last column. And finally you see that we can find out the mean rho, the average of this all 4 values in this method. Okay. So this is our aim, this is actually our aim, and also side by side we have verified Ohm's law just by showing that all the R values will come almost same. The V by I ratio, if we take the V and I values corresponding, all the V by I values will come same. Okay. So this is the entire process I just described. Now I will show you in the instrument how to take the readings. Fine. Now see the circuit. Okay. Now we will do the experiment here physically, like the circuit is as already made as I have shown you the circuit. Now I am switching on this power supply. Here you can see that the voltage, the DC voltage which has been applied over here is 1.5 volt. This value is written over here 1.5 volt. So that is the applied voltage in this entire circuit. Now what we will do, our first task is to slide the rheostat. So I will do that slowly, and you will see there will be deflections in this millivolt meter as well as in milliammeter, both the deflections to be seen accurately. Okay. Now see, I am sliding this rheostat. First you see the deflection, then we will take one reading. So this way it is understood that when we are varying the resistance in the circuit, a current starts flowing through the circuit which is also passing through that particular unknown resistance, and as a result a potential drop is shown by this millivolt meter. So now one reading we will take. Suppose this is a particular reading, suppose I am taking this is a particular reading. Now see here, first the current, as I am telling about the current, Here I told the least count is 5 milliampere. Now let us count the number of divisions the pointer has moved. Here it is seen 1, 2, 3, 4, 5. So 5 divisions. Here you can see the 5 divisions. You see 5 divisions, it is shown here. So the current here is 25 milliampere. So 25 milliampere current is actually flowing through this circuit now. Okay, because this is connected in series in the main path, so it is showing the total current flowing through the circuit as well as the current flowing through the unknown resistance also. So 25 milliampere is the total current for the first observation. Okay, so our first reading will be 25 milliampere. Similarly, for here the reading is, you can see that it has gone a distance of, I am telling you, 1, 2, 3, 7 divisions, 7 small divisions the pointer has moved in the millivolt meter here. So it is 7 into 5, that is 35 millivolt. So 35 millivolt is the potential drop which is actually occurring across this unknown resistance which is given. Okay, so we got the current as we told that 25 milliampere and here 35 millivolt. So we got 2 readings. Now I will write in the board. Now here I am writing the current as 25 milliampere. The first reading is 25 milliampere and the potential difference in millivolt is found to be 35. Okay, so what is the resistance here? R equals to V by I. V by I, that means 35 by 25. Here I am not converting milliampere into ampere or millivolt into volt because both the factors are same here, 10 to the power minus 3. So ultimately they are going to get cancelled. So 35 by 25, or we can say like 7 by 5. So it is found to be 1.4. So this is the first reading where the resistance is found to be 1.4 ohm. This is for the first observation. Now using the formula, if you see this side, using this particular formula, here R is 1.4 ohm, pi is 3.1416 and diameter D, as I told, 33 millimeter is found to be, and L is 30 centimeter. You have to convert this in meter, 0.3 meter. So if we put all the values, we will get the value of rho for that particular material. The resistivity value in ohm meter we will find out. So that is the first observation. So from the first observation, the first value of rho, that is rho 1, that we are going to get from this calculation. Similarly, if we carry out other observations in the same manner by varying the resistance in the rheostat, we can have different values of R and correspondingly we can have different values of rho, and finally we can have a mean rho by this particular formula. So this is all about the value of resistivity using a tabular presentation. Now we need to do a graphical analysis. So students, as I told that we have done the tabular presentation of data, and from the tabular presentation we have found out the value of resistivity of the material of the given wire. Now as I told that we have to do the a graphical analysis also. So the graph we need to draw here, it will be a graph between the current I in milliampere and the potential drop V in millivolt. So as we know, we are doing an experiment based on Ohm's law. So obviously the conductor or the material by which the resistor is made, it is a ohmic conductor. So it will be a linear graph. So the graph we will get which will be passing through the origin. Okay, if we plot all the points from the table, we will get a graph and that will be passing through the origin of this particular coordinate axis. Okay, now from this graph, suppose we are getting some points here, some points suppose we are getting, and we have to find the slope of this graph, because the slope of this particular graph will give the resistance. Okay, so let us choose some arbitrary point. We should not take the points which are in the tables. Okay, so we should take some arbitrary point. Suppose I am taking this point, I am taking this point, and we have to drop a right angle triangle. Okay, so the slope, this value is actually dV, this value is dV, and this value is actually di. So the slope of the graph, which is basically the resistance R, equals to dV by di. So this way from the graph we can find out the resistance of that a mean resistance, you can say it is a single valued only. So we can have a single value of the average resistance or mean resistance we will get from the graph. Now using this value of resistance and using other parameters like the length of the wire and diameter of the wire, we can find out its resistivity. So we can cross check the values of resistivity obtained from the graph as well as from the observation table. Okay. So this is the entire experiment. So today we learned that through this experiment how could we verify or re-establish Ohm's law, as well as we could find out the resistivity of the material of a given wire. Thank you, students.